Welcome to the Elon Musk Signal channel. After the fourth test flight, we are all eagerly anticipating the fifth launch of Starship, aren't we? The biggest concern right now is how prepared SpaceX is for the fifth flight. In today's video, we will explore the latest developments at Starbase, including the installation of thermal shields for Ship 30 and the first test of Booster 14.1 at the launch pad. Let's get started. First, let's delve into Ship 30. The overhaul of the Starship's thermal protection system has been truly spectacular. Over the past few weeks, SpaceX has undertaken a comprehensive refurbishment thermal shield system. Watching impressive footage from Starship Gazer, it's clear SpaceX has begun removing the entire old thermal tile layer from last week. Simultaneously, they've installed a new ablative layer and a star tile layer. This marks a remarkable step forward in completing upgrades before the launch, something that was hard to envision before. Detailed close-up images reveal significant changes in the new generation thermal protection system of Starship 30. The nose cone is temporarily equipped with a thermal tile layer, fixed with adhesive tape, and without the need for an abrasion-resistant layer underneath. A key enhancement is the reinforced collar at the front with an added layer of blade-like material. This additional layer serves as a crucial element, protecting the core and body of the spacecraft from damage in critical areas. In case of tile peeling, this material layer initiates an ablation process upon exposure to high plasma temperature. Ablation is accompanied by gradual burning, effectively dissipating heat. This is part of the concept of invasive thermal shielding, a last resort protection method that, while not reusable, is proving highly effective in SpaceX's research on heat resistance during atmospheric re-entry. One of the most notable highlights is the breakthrough thermal tile-less tests. These experiments involved two configurations, one with a single-layer insulating material and one with a dual-layer insulating material. Results indicated that the single-layer configuration did not sufficiently prevent heat penetration, resulting in burn-through on the steel layer below. Conversely, the dual-layer configuration successfully prevented burn-through, providing crucial data for refining the Starship thermal protection system in future flight. Improvements in TPS materials and construction techniques are expected to significantly enhance the system's performance, ensuring spacecraft safety in harsh atmospheric re-entry conditions. Additionally, aerodynamic performance is a particularly focused area. Details regarding severe damage to control surfaces in previous test flights confirmed suboptimal aerodynamic performance. The correlation between visual damage and poor aerodynamic performance serves as foundational data for optimizing designs in future iterations. While moving forward control surfaces to the windward side holds potential for significantly improving heat resistance and aerodynamics, implementing this change requires a redesign of the entire nose cone. Therefore, this is considered a long-term goal for SpaceX's Starship rather than an immediate adjustment. Currently, Ship 30 is being prepared for its fifth flight, focusing on optimizing re-entry resilience by reinforcing vulnerable components. Additional mass required to enhance efficiency and durability of the control surfaces can be partly offset. Next is the launch pad area, where testing activities for Booster 14.1 are underway. This is a crucial test step towards the ambitious plan of capturing and reusing the Super Heavy booster in the fifth Starship launch. SpaceX is actively conducting simulations of the landing process to demonstrate the reusability of the booster, a pivotal factor in achieving commercial space travel goals. Booster 14.1, the largest test stand ever constructed by SpaceX to date. Standing at a towering 11 stacked cargo bay heights, Booster 14.1 mimics the structure of an official propellant tank, comprising a cluster of 4 propellant tanks, forward pressure dome, and a shared pressure dome cluster. Following the successful Crusher test at McGregor, Texas, Booster 14.1 proceeds to another crucial testing phase. Primary objective is to test the durability of lift and capture posts, pivotal components of the chopsticks mechanism used to raise the Super Heavy booster onto the launch stand. Equipped with dedicated lift posts, Booster 14.1 simulates the forces exerted during the actual Super Heavy booster capture. Immediately lifted onto the test stand by the GMK 7550 crane from McGregor, Booster 14.1 was transported directly to the launch pad. Its presence at the test stand indicates SpaceX's deeper rocket capture testing preparations for the planned Booster 12 capture on June 26. As observed in previous tests, Chopstick's arms encountered some difficulties in braking due to excessive vibration from its mass and inertia. To address this issue, SpaceX conducted its first test related to the Chopstick's arms. In this test, the left arm was raised and moved into the test cradle, simulating the impact of capturing the booster. The test was repeated 3 times at different speeds and collision forces. After each collision, engineers meticulously inspected the test cradle for any signs of damage. The goal of this test is to gather data on how the Chopstick's arms absorb impact forces and transfer energy to the launch stand. This data will be used to fine-tune the arm control system and ensure it can safely capture the Super Heavy booster in the 5th Starship launch. At the test site, in the coming days, SpaceX plans to conduct 2 main test scenarios, simulating the process of capturing the Super Heavy booster using the Booster 14.1 test stand. 2 scenarios are proposed. The safer first scenario will replicate steps after the rocket touches down. Specifically, the Chopsticks will lift Booster 14.1 to simulate the contact point between the booster and Chopsticks during actual landing. Engineers can then perform adjustment operations before safely returning the booster to the launch pad. However, the second scenario is more daring and likely to occur. The drop test. Yes, SpaceX may drop this giant steel tower onto the Chopsticks. The sequence is expected to unfold as follows. Chopsticks will expand to full size, ready for capture. The L-100 giant crane will raise Booster 14.1 high, then drop it. The landing gear on the Chopsticks is designed to move up and down, absorbing the rocket's falling force. This bold test will help confirm many critical aspects of the rocket capture system. It will demonstrate the current Super Heavy design's ability to withstand falling forces, simulating scenarios such as sudden rocket engine shutdown. Furthermore, the test will evaluate Super Heavy's impact resistance in imperfect landing conditions, providing SpaceX with valuable real-world data before the 5th planned rocket capture. Despite the increased risk, referencing this daring drop test is entirely rational. Thus, we have explored SpaceX's test facility and learned about their latest advancements in the ambitious pursuit, capturing the Super Heavy booster, with crucial tests playing a key role in ensuring safety and success for the 5th Starship mission, marking a significant step in SpaceX's journey to Mars. Those are the noteworthy details featured in today's video. Thank you for watching. Please leave your comments on this broadcast and stay tuned for upcoming exciting events on the Elon Musk Signal channel. Don't forget to subscribe and turn on notifications to catch more fascinating videos on the Elon Musk Signal channel. Goodbye, and see you next time.